We will start our first module, which is differential equations. We are all familiar with equations involving derivatives. If we consider an equation of the form y equal to f of x, then it means y depends on x. Y varies according to the variation of x. X can independently choose values, and according to the values of x, y also takes some values. Okay, so y depends on x. That is called y is the dependent variable. X can independently choose values. X is called the independent variable. Okay, we consider equations having dependent variables and independent variables. Suppose we have a dependent variable y which depends on a single independent variable x. We can consider the variation of y with respect to x. Okay, the y is completely determined by x. So the rate of change of y can be completely determined according to the variation of x, and we write it as dy by dx. The rate of change of y with respect to x is the derivative of y with respect to x, and we denote it by dy by dx. Okay, but if we have the dependent variable z, and if it depends on more than one independent variable, suppose z depends on x and y. So there are two independent variables, one is x and another is y, and z depends on two independent variables. Okay, so we can consider the rate of change of z partially with respect to x and partially with respect to y. If we consider the rate of change of z with respect to x, it cannot completely determines the rate of change. There is also rate of change with respect to y. So there, with respect to x, there is only a partial change in z, and with respect to y also there is only partial change. So to consider the rate of change of z completely, we have to consider the partial derivatives with respect to x and also with respect to y. So we use the symbols dou z by dou x and dou z by dou y to represent there is a partial change in z with respect to x and a change in z with respect to y also. Okay, so the equations which involves total derivatives are called only total derivatives are called ordinary differential equations, and if there are partial derivatives also, that is the partial derivatives with respect to different independent variables, then it will be a partial differential equation. Ordinary differential equations, that is ODE, and partial differential equations, that is PDE. Okay, so ordinary differential equations occur only if there are a single independent variable. അപ്പോൾ ആ ഡിപ്പെൻഡന്റ് വേരിയബിൾ ഇഫ് ഇറ്റ് ഡിപ്പെൻഡ്സ് ഓൺലി വൺ വേരിയബിൾ then its rate of change of is complete with respect to that variable, and we use the symbol total derivative dy by dx. Okay, if the dependent variable depends on more than one independent variables, then there its rate of change can be determined according to the rate of change with respect to different independent variables, and there will be partial derivatives. Okay, so remember, ordinary differential equations occur if there are only one independent variable, and partial differential equations occur if there are more than one independent variables. More than one independent variables in the case always exist partial differential equations, and if there is only one independent variable, only one independent variable, it will be an ordinary differential equations. So differential equations involving derivatives is called a equations involving derivatives are called differential equations. They are classified into two: ordinary differential equations and partial differential equations. Ordinary differential equations includes only ordinary derivatives which occur if there is only one independent variable. Partial differential equations involve partial derivatives that happens when there are more than one independent variables. Okay, so here we consider in the first module only ordinary differential equations, that is equations with only one independent variable. There may be more than one dependent variables. അത് നമ്മൾ കൺസിഡർ ചെയ്യേണ്ട കാര്യമില്ല. ഡിപ്പെൻഡന്റ് വേരിയബിൾസ് ഒന്നാകാം, ഒന്നിലധികമാകാം, but there should be only one independent variable. Okay, such equations are considered as ordinary differential equations. So we begin with ordinary differential equations. Equations involving a single independent variable. Okay, there may be more than one dependent variables. Consider ordinary differential equations. Okay, we first define what is the order and degree of an ordinary differential equation. Okay, consider the differential equation, say d square y by dx square plus 2 dy by dx plus say sin x into y equal to e raised to x plus. Consider this differential equation. Okay, here there are first order derivatives dy by dx and second order derivatives say d square y by dx square. We consider each term of the differential equation, first term, second term, etc. involving derivatives. Derivatives ഉള്ള ഓരോ ടേം നോക്കുക and consider the term with the highest ordered derivative. Here the highest order derivative, the order of the it is a first order derivative. Here it is a second order derivative, and the highest order is 2. So the order of the whole differential equation is considered as 2. That is, order of a differential equation is the order of the highest ordered derivative occurring in the equation. Okay. The order of the highest order derivative occurring in the equation, in the ordinary differential equation, is called its order. It is the given differential equation is of second order. Okay. If we consider d cube y by dx cube minus dy by dx the whole cube equal to 0, then there are terms with first order derivatives and third order derivatives. The highest order derivative, that is the orders are 1 and 3, the highest order is 3. So the differential equation is considered as a differential equation of third order. Okay. Now after defining the order, we can specify its degree. The degree of the differential equation is defined as the degree of the highest order derivative occurring in the equation. Okay, നമ്മൾ highest order ഡെറിവേറ്റീവിന്റെ ടൈം മാത്രം കൺസിഡർ ചെയ്താൽ മതി. അതിന്റെ ഡിഗ്രി എന്താണ്? That is d square y by dx square. This is raised to 1. Okay, so it is a second order differential equation of degree 1. Consider d cube y by dx cube. It's a third order degree, maximum order is 3. And its degree is also 1. So it is a first degree equation. If we consider this as d square y by dx square the whole square, then its degree is 2. So suppose d square y by dx the whole square plus 2 dy by dx the whole cube plus sin x y equal to e raised to x plus 2. Here also we consider only the term with the highest order derivative and its degree is 2. അപ്പോൾ ഇവിടെ there is a first order degree order term and its degree is 3, but it is not the highest order term in that differential equation. So we consider, to find the degree and order, we consider only the highest ordered derivative term. The order of the highest order derivative is the order of the differential equation, and the degree of the highest order derivative is the degree of the differential equation. Now if we define, while defining the degree of a differential equation, we have to consider only integral powers. If there is any radical power or if there is any fractional power, we have to completely avoid that by taking the appropriate power. Okay. For example, if we have root of dy by dx minus 2x equal to 0, consider such a differential equation. Clearly, it is a first order equation because the highest order derivative is first order. It is dy by dx. Okay, and order 1 ആണ്. അതിൻ്റെ അകത്ത് വേറെ നമുക്ക് ഒരു സംശയമില്ല. പക്ഷേ ഡിഗ്രി പറയുമ്പോൾ ഇവിടെ നമുക്ക് റാഡിക്കൽ സൈൻ ഉണ്ട്, ഒരു ഫ്രാക്ഷണൽ പവർ ആണ്. dy by dx raised to 1/2 ആണ് ഈ ടൈം. So we have to clear the power. We represent this equation as root of dy by dx equal to 2x. Square both sides, it is dy by dx equal to 4x square, or dy by dx minus 4x square equal to 0. So its order is 1 and degree is also 1. Okay. Now if we consider this equation as, say, d square y by dx square raised to 2/3 minus 4x cube equal to 0. Here the order of the differential equation is 2 because the highest order term is 2. ഇവിടെ ഒരു ടൈം say dy by x equal to 0. Now, to find the degree of the differential equation, we rewrite this equation as d square y by dx square raised to 2 by 3 equal to 4x cube into dy by dx, and take raised to 3 on both sides. Cube, this also cube. That is d square y by dx square raised to 2 equal to 4 cube 64 x cube raised to 3 into dy by dx the whole cube. Okay. Now for this differential equation, the order is 2 and it is the highest order term, its degree is 2. So it is second order and second degree. But first order term on the degree 3 ആണ്, പക്ഷേ we will not consider it as the degree or order of the differential equation. We consider only the highest order term. Highest order term in the degree order ആണ് differential equation order. Highest order term in the degree ആണ് differential equation degree, provided it is free from all fractional powers. Okay. So this is differential equation, ordinary differential equation, its order and degree. Now we consider differential equations, how we can form differential equations from given relations of x, y, z. Okay. Consider y equal to f of x. The equation, we know it is it can be represented as a graph in the xy plane. അത് ഏതോ ഒരു ഫംഗ്ഷന്റെ ഗ്രാഫാണ്. Okay, this is f of x. Y equal to f of x. We take the values of x. This is the value of y and we write this as the curve f of x. Okay, so any equation of the form y equal to f of x can be represented as a curve in the plane, and dy by dx represents the rate of change of y with respect to x, we know, but here we geometrically we consider it as the slope of the curve. The slope of the curve y at the point x. Dy by dx represents the slope of the curve at x. Okay, so this is the physical interpretation of the derivative for equations of the form y equal to f of x. We consider the equation, consider x square plus y square equal to a square. We know it represents a circle with the center at the origin and radius is a. Depending on the value of a, we get a family of circles. All have the center 1. For example, x square plus y square equal to 1. It represents a circle of radius 1. Okay. X square plus y square equal to 4. It represents a circle with the radius 2. Okay. X square plus y square equal to 9 represents a circle with the radius 3. According to the value of a, we get a family of circles. All depends on this. And the ബാക്കി എല്ലാ പ്രോപ്പർട്ടീസ് സെയിം ആണ്. സെന്റർ വിൽ ബി ദ സെയിം ആൻഡ് നേച്ചർ എല്ലാം സെയിം ആണ്, പക്ഷേ അതിന്റെ റേഡിയസ് മാത്രമാണ്. So we call it as a as a parameter, and we represent x square plus y square equal to a square represents x square plus y square equal to a square represents a one parameter family of circles. Okay. Or generally, this equation can be written as y square equal to a square minus x square, or y equal to plus or minus root of a square minus x square. Y depends on x and a, where a is considered as a parameter. As a varies, we get a family of circles. All have the center, the origin. So its general form is y equal to a function of x and a. Y equal to a function of x and a. Such equations or such curves are called one parameter family of curves. One parameter family of curves. Okay. So the general representation of one parameter family of curves is y equal to f of x. Or it can also written as f of xy equal to a. There exists only one parameter a. Okay. These are one parameter family of curves. If there is only one parameter, we can eliminate this parameter. This parameter suppose we are differentiating with respect to x. This is 2x plus 2y into dy by dx equal to 0. Differentiating this equation with respect to x, we get 2x plus 2y dy dx equal to 0, or cancel 2, we get dy by dx equal to minus of x by dy by dx equal to minus of x by. So it is a first order differential equation. Dy by dx equal to minus x by y represents a first order differential equation. So if we have a one parameter family of curves, by eliminating that parameter, we get a first order differential equation. Its general form is a function of the form x, y and dy by dx equal to 0. ഇതായിരിക്കും അതിൻ്റെ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ്റെ ഫോം. എക്സ്, ദർ ആർ വേരിയബിൾസ് എക്സ് ആൻഡ് വൈ ആൻഡ് ഫസ്റ്റ് ഓർഡർ ഡെറിവേറ്റീവ്സ്. അപ്പോൾ ഈ ഡി വൈ ബൈ ഡി എക്സ് അതിൻ്റെ ഓർഡർ എപ്പോഴും വൺ ആയിരിക്കും, പക്ഷേ ഡിഗ്രി വേണേൽ എന്തെങ്കിലും ആകാം. ഡി വൈ ബൈ ഡി എക്സ് ഹോൾ സ്ക്വയർ, ഡിഗ്രിയെ കുറിച്ച് നമ്മൾ സ്പെസിഫൈ ചെയ്തില്ല, പക്ഷേ ദാറ്റ് relation involves x, y and dy by dx equal dy by dx. So remember, if we consider a one parameter family of curves, then by eliminating that parameter we get a first order differential equation. Okay. Similarly, if we consider the equation curves of the form x square by a square plus y square by b square equal to, suppose 1. X square by a square plus y square by b square equal to 1. It represents family of ellipse. Okay, x square by a square, on the x axis it intercepts at plus or minus a, y axis it plus or minus b. Its general form is a function of x, y, a and b equal to 0. A and b are, according to the different values of a and b, we get different ellipses having the same properties. Okay, so there will be a family of ellipses with two parameters a and b. Such equations are called a two-parameter family of curves. And by eliminating a and b, the parameters from this equation by differentiation, we get a differential equation of second order. A function involving x, y, dy by dx and d square y by dx square equal to 0. At least one second order derivative എങ്കിലും കാണും. ഫസ്റ്റ് ഓർഡർ ഡെറിവേറ്റീവ്സ് മേ ഓർ മേ നോട്ട് പ്രസന്റ്. നമുക്ക് സെക്കൻഡ് ഓർഡർ ആണെങ്കിൽ നമ്മൾ മാക്സിമം ഓർഡർ 2 ആയാൽ മതി, അല്ലാതെ വൺ ഓർഡർ ഉണ്ടോ ഇല്ലയെന്ന് നമ്മൾ നോക്കേണ്ട കാര്യമില്ല. സോ എനി റിലേഷൻ ഇൻവോൾവിംഗ് എക്സ്, വൈ, ഡി വൈ ബൈ ഡി എക്സ് ആൻഡ് ഡി സ്കോർ വൈ ബൈ ഡി എക്സ് സ്കോർ ഈക്വൽ ടു 0 will represent a second order differential equation. So remember, if we have a two parameter family of curves, then by eliminating that parameters we get a second order differential equation. Similarly, we can define three parameter families and third order differential equations as, consider the equation x minus a the whole square plus y minus b the whole square plus z square equal to 1. Consider equations x minus a the whole square plus y minus b the whole square equal to c square. It represents family ആണ്. അതിൻ്റെ അകത്ത് 3 പാരാമീറ്റേഴ്സ് ഉണ്ട്, എയും ബിയും സിയും. അതിൻ്റെ ജനറൽ ഫോം എന്ന് പറയുന്നത് എഫ് ഓഫ് എക്സ്, വൈ, എ, ബി, സി ഈക്വൽ ടു 0 ആണ്. ഇറ്റ് കോൾഡ് 3 parameter family of curves. By eliminating all the 3 parameters, we get a differential equation involving x, y, dy by dx, d square y by dx square and d cube y by dx cube equal to 0, which represents a third order differential equation. So the only point is that if we consider a one parameter family of curves, by eliminating the parameter we get a first order differential equation. If we have a two parameter family of curves, by eliminating the two parameters we get a second order differential equation, and as so on. So we can consider some problems relating how we can form the differential equations from given relations of x and y. Okay. Consider the equation y equal to x square plus y equal to x square plus. We know it is a one parameter family of curves because there is only one parameter, say c. So if we eliminate c from this equation, we get a first order ordinary differential equation. Just differentiate with respect to x, we have dy by dx equal to 2x. Okay, dy by dx equal to 2x, or dy by dx minus 2x equal to 0. It is the differential equation representing this family of curves. Okay. Consider y square equal to e raised to 2x plus c. This is also a one parameter family of curves. Differentiating with respect to x, we have 2y into dy by dx equal to 2 e raised to 2x. Okay, 2y into, we can cancel 2 from both sides, and this is y into dy by dx minus e raised to 2x equal to 0, which is free from all parameters, and there is it represents a first order differential equation. Okay. Now consider a two parameter family y equal to c1 into sin 2x plus c2 into cos 2x. Form a differential equation from this relation. Here there are two parameters c1 and c2. So by eliminating c1 and c2, we get a second order differential equation. Differentiating this equation, we get dy by dx equal to sin 2x, its derivative is 2 cos 2x. So 2 c1 into cos 2x plus cos 2x derivative minus ആണ്. So minus 2 c2 into sin 2x. This is equation 1. This is equation 2. Okay. Now differentiating again, we have d square y by dx square equal to minus 4c1 sin 2x minus 4c2 cos 2x. Equation 30. Minus 4c1 sin 2x minus 4c2 cos 2x. This is minus 4 into c1 sin 2x plus c2 cos 2x. Okay, which c1 sin 2x plus c2 cos 2x, from equation 1 we can represent this as minus 4. This is our given function y. So we get d square y by dx square plus 4y equal to 0, which is free from all arbitrary or all parameters, and it is a second order differential equation. Okay, so eliminating two parameters from a given relation, we get a second order differential equation. Similarly, consider the equation y equal to ax square plus bx plus c. There are three parameters a and b, a, b, c, a, b and c. So by eliminating all these constants, we get a third order differential equation. Just to differentiate, dy by dx is 2ax plus b. D square y by dx square equal to 2a. D cube y by dx cube equal to 0. This is a relation, a third order differential equation, which is free from all parameters. So d cube y by dx cube equal to 0 is the differential equation representing this relation or this family of curves y equal to ax square plus bx plus c. Okay.